All right, Precalc, let's keep digging in. We are still on Chapter 4, Section 3, and this question is regarding trig identities. They're telling us to verify. Now, verifying, unfortunately, guys, you have to show all your work. And we want to verify that the cotangent squared theta is equal to 1 over sine squared theta minus 1. So the first thing that I'm going to do is change that sine squared theta to its flip. So that is cosecant squared theta minus 1. Well, we're very close to a trig identity that we learned. I'm going to add 1 to each side. Cotan squared theta plus 1 is equal to cosecant squared theta is where I'm going to keep this, because if you can remember our trig identities, cotan squared theta minus or plus 1 is equal to cosecant squared theta. And I think that's where we landed. All right, so my notes aren't very good, but we're moving on to example 6. It says a surveyor is standing 50 feet from the base of a large tree. Well, I'm going to give you a hint. Always draw a picture. Okay, so I'm going to draw a tree. Somehow my tree does not look very good. I'll make it prettier. We'll make the base of it. And I know that a surveyor is standing 50 feet. So this is 50 feet, and here is a surveyor standing. The surveyor measures the angle of elevation to the top of the tree as 71.5 degrees. How tall is the tree? Well, I'm at home and I don't have my graphing calculator with me, but I know that I could use the sine of 71.5 degrees, the sine of 71.5 degrees, hint, hint, we need our calculator in degrees, is equal to, well, I need to know this height right here. And notice I just created a very rough sketch of a right triangle. So I know I can call this x over 50. To solve this, I would have to multiply each side by 50. So I know in my calculator x is equal to 50 times the sine of 71.5. All right, I had to run and find a different calculator, and I did find a TI-30, and it still has that sign, so I didn't actually have my calculator. But when I take 50 times sine of 71.5, I get 47.4. So it's kind of a tall tree, but I believe that is the answer. And remember, they're talking about the feet of a tree, so that is 47.4 feet. Let's look at another word problem. I want to go over this one. This one's just a 45-45 angle, so I'm not going to go over that one. We'll do it in class. This one I like because now we have to find theta, which is the angle. It says a ramp 17.5 feet in length rises to a loading platform that is 3.5 feet off the ground. Find the angle theta that the ramp makes with the ground. So this is going to be a little bit of a different ball game. Now I still have opposite over hypotenuse, so am I going to use SOHCAHTOA or TOA? We still have a right triangle, so that's good. We're going to find the sine of theta, and we're going to make that equal to opposite. I'm going to call that 3.5 just because that's easy, over hypotenuse 17.5. Now putting this in our calculator is a little different. Whenever we're looking for theta, we're going to use, well, there's a couple ways to do it. I like to take, in your calculator, you're going to take second and sine, and up pops this sine to the negative first. And inside of there, I can take the 3.5 divided by 17.5, or you can find this first and then throw that answer in there. But I like to just do it in one step. So remember, again, your calculator has to be in degrees because it says find the angle theta that the ramp makes with the ground. We don't typically talk in radians. And when I go ahead and put this in my calculator with the inverse, I get 11.5 degrees.